Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, I'm doing a follow-up of my last video on Raspberry Pi networking. In the last video, I talked about the Wi-Fi side. This week, I'm going to be talking about the wired Ethernet side. I want to talk about what I did in my last lesson that I posted, which I think was lesson 28, where I had two Picos connected with different IP addresses. I had 10.20.20.201 for the Sunfounder and .202 for the GeekPi. And what was not obviously apparent to you is how that was wired together. So I want to show through this diagram how I had it set up. And as you can see, I had an access point set up just for my kind of top Tech Boy lab environment. And I have it set up with the 10.20.20 subnet. Now, to make connection easy, I connected the Pi 4's Ethernet port to the LAN side of the access point. So everything was 10.20.20. The Raspberry Pi could talk to the access point, the Raspberry Pi could talk to the Picos, and vice versa. Everything was communicating. And I wanted to show you briefly how I accomplished this. I used the Etsy network interfaces file to define a static IP address on ETH0. I took out any other references to ETH0 in that file, and this is what I put in, just a simple ETH0 iNet static, here's my IP and subnet mask. Then I also had to go into the DHCP client config. Now pay attention to what this file is named, etc dhcpcd.conf. dhcpcd.conf is the client configuration. dhcpd.conf is the server configuration. For today's video, we're not going to talk about the server, but I want to make that clear so that you understand which file you're modifying. And I put this deny interfaces line in here because I wanted to show, where's my finger pointing? My finger's not pointing the right direction. There we go. I wanted to show that we are telling the client, do not try to get an IP on ETH0. I statically defined it in interfaces. I don't want it to be dynamic via the DHCP client. Now, all of this worked well, except you can see in the center what my problem is. I cannot reach the internet from my Pico. My Pico is on this side of the world, the internet's on that side of the world, and the two cannot talk. So I need to make some changes in how I'm configuring my network. So what I've done is I've gone in and I've reconfigured. I'm sorry for the eye chart here, but I did add a few components and some additional configurations, so I wanted to walk through that. The first thing I did is I separated, I'm getting really, the finger pointing's not working, so you'll just have to follow along with your eyes. I separated the Pi and the wireless access point, and over on the far right, you can see I've got the Picos still configured with their IP addresses, talking to the access point. However, there's a configuration change between the Pi 4 and the access point. Instead of being part of the LAN connecting, I switched it to the WAN side. Now, the problem with that is that I've introduced a firewall, and I will get to that later in this video on how we accomplish that. But what I've got is I've got an actual route from my Picos from the 10.20.20 subnet to the 10.20.30 subnet, which is where the Pi 4 is configured. And if we look at the configuration below, you can see I've given it basically the same configuration, just a different subnet, 10.20.30 instead of 10.20.20. And again, I've denied ETH0 in the DHCP client config. I don't want the client trying to grab an IP address on that network. And then in order to accomplish routing, I needed to make some firewall changes. So I installed a package called Firewall D and started and enabled it so that it runs on every boot. But then I had to make some changes to the firewall because by default, it pretty much blocks everything. So I had to set up this add masquerade line with a permanent flag, so that way it's going to be persistent between reboots. But what that's going to do is it's going to masquerade. It's going to take any IP address that's 10.20.30 and masquerade it as the Pi's address on my Wi-Fi network. That's how we accomplish the outbound routing. I've also added specifically the 5900 to 5910 ports. That is so that if I connect a device like a laptop or another Pi to this network, I can reach the Pi 4 via VNC. That was kind of critical when I was setting up and testing it. I wanted to make sure everything was working properly, and I wanted to get to the full-fledged desktop of my Pi. I didn't want to just SSH in. And then do a reload and then a list just to make sure that everything is configured the way we expect it to. So what's the impact of this? Well, let's talk about, first of all, how the router is configured for the Picos. Now here I have a really simple setup. I have two reserved addresses, 201 for the SunFounder Pico, 202 for the GeekPi Pico. And I talked at length about MAC addresses in my last video. In this case, I'm not setting the MAC address of the Picos, nor am I setting the device name. But as it turns out, according to the documentation, we do have the ability to do this in MicroPython. We can actually set the MAC address, we can set the host name, we can determine what shows up on the router. In this case, I didn't do it. It wasn't worth it to me to set the MAC addresses of the Picos and host names and so forth, namely because I want to be able to take one piece of code and just drop it on whatever Pico and it's going to work the same way. So I didn't bother doing that. Now, there's obviously a problem here in that I've introduced a firewall between the Raspberry Pi and the router. The Raspberry Pi Picos can get out, but the packets can't get back in because there's a firewall. So how are we going to deal with that? This comes up, I thought about this because there was a question brought up in the chat, and I realized it was several months ago. Someone was asking, could I actually make an internet accessible PicoW? Can I, write my client, put this thing on the internet and actually have somebody on the other side of the internet connect to it and run commands? And I think it's possible, but let's talk about how we would do that. We have to enable port forwarding on our router. So what I have is I have my external interface on this router, which is 10.20.30.1, port forwarding to the internal interface, which is 10.20.20.1. And what we can see here is I've actually gone in and created some port forwarding rules. The SunFounder is going to be using port 2012 on the outside to map to port 2222 on the inside. The GeekPi is going to be using port number 2022 to map to 2222 on the inside, but notice it's the different IPs. This is a little hard to explain, so that's why I wanted to make sure I put up a graphic. The SunFounder Pi, or the SunFounder Pico, is going to be connected to, on the external interface of the router, on port 2012. The GeekPi is going to be connected to, on the external interface of the router, at port 2022. Now, that might not make a lot of sense, so let's go and let's take a look at our Pico setup. Oh, something changed. What did I do here? So I talked about it in one of my previous videos. I love the battery module, but I really don't like the connector. I don't like the needing to either unplug it from the Pico or have to unplug this connector. It's all kind of fragile, and you really do run a risk if you're in a hurry and you plug this connector in wrong. If you get it off by one pin or another, you could potentially destroy your Pico or the battery. And I don't want to destroy a lithium battery. That sounds very flamey. So let's not do that. What I've done is I've taken the power lead into this more fragile connector. I've split it off to two less fragile yellow wires, and then I attached a switch. I do have a more suitable switch for this, but given that I was just trying to get it working, I grabbed a spare electrical wall switch. Kind of tacky looking, but it works. And now what I can do is I can just flip the power on like that, and we can see that my GeekPi Pico is coming up, and it's got its IP address of 10.20.20.202 as we expect, and we're ready to go. So let's take a look. Is this going to be the right view? That is not the right view. There we go. So here's the client that I used in my previous video, and we can see that the Pico SunFounder and the Pico Geek Pi are separated by IP address. Everything was on the same network, so I could hit 201 for the SunFounder, 202 for the Geek Pi, and I'll move the mouse cursor here, and that port number was 2222. And we can see we're using the same port on both Picos. That's what our listener is set to for that port number, and we're just differentiating between IP. Well, I needed to make a slightly modified version of the client that accommodates the fact that our IP address is the same, but our port number changed. So here's the IP address, 10.20.30.20. That's the external interface of my router. And the SunFounder is using port 2012, and the Geek Pi is using port 2022. So now, of course, the question is, does it work? Can I send commands from my Python client on the Raspberry Pi through the firewall to the Pico on the other side? Well, let's find out. So I can type hello, and let's flip views here. Where is there we go. I do apologize for the focus. It's about as good as I could get it. So there we go. I've sent my hello command. Let's send a command. Let's do spinning potato chip. And we can see I'm doing spinning potato chip. And again, the Pi is on one side of the firewall. The Pico is on the other. So I'm basically simulating what it would look like to have a client way out on the internet somewhere connecting into my home network through my firewall into the Pico. And of course I can do some LEDs, if I can type it right. There we go, turn them all on. LED, let's turn one off, and all off, and I can still do my RGB. So let's do RGB blue. And I think this is a special occasion. We're sending commands from a Raspberry Pi through a firewall, through a router, to a Pico on the other side, and obviously the commands are getting through. So I have no problem saying that this is a special occasion. And then, of course, I can send the goodbye to shut down the Pico, and of course, exit to exit the client. So I hope that was interesting. I hope that was useful to understand more about the Linux networking side, but also show this proof of concept of what it would look like to actually internet connect to Pico. It should be doable. Unfortunately, as you might imagine, my home network is a bit over-engineered. I actually have several firewalls in place. So poking a hole through from my externally facing internet address to something on the inside would take more than just setting up one single port forwarding rule. It would take quite a bit of effort. It's something that I'm hoping to do in the future, but for now I just wanted to get it working in a lab environment to prove that it can be done. And of course, if you're interested in trying this yourself, I would encourage you to give it a try, post a video, and let us know how it all went. All right, so with networking behind us, I'm going to get back to doing some Pico homework. Thank you for watching. If you haven't subscribed yet, be sure to hit subscribe, hit like, and leave a comment if you wish. For Simply Brian Enterprises, this is Brian. Thank you for watching, and I will see you later.